Alrighty, in the last lection we were using this SOH-CAH-TOA thing to solve for missing angles in a right triangle, always a right triangle. This time we ramp it up just a little bit. Actually, we don't ramp it up, we just extend it a little bit by finding sides, missing sides in a right triangle. Again, it has to be a right triangle. So all I'm doing here in this diagram is saying, hey, let's recall how this SOH-CAH-TOA thing works. So you've given a right triangle, it has to have a 90, and then you're interested in one of these two acute angles, the sharp angles, and let's say it's this one. Well, if this is your angle of reference, then you come all the way across the middle to the opposite side of the triangle and you say, hey, that's the opposite side of the triangle, that's what that is. Remember, the hypotenuse is always the hypotenuse. It is what it is. It's the biggest side of the triangle. And then this leftover side, so to speak, is the adjacent side. You're kind of standing on it. The adjacent side. And what matters the most is which angle are we talking about? Because if we were talking about this angle, if I came through the triangle to the opposite side, that would be the opposite side. Not that one, that one, right? And this would be the adjacent because you're practically standing on it, because you always know which one's the hypotenuse. So anyway, let's get rid of that mess. Why did I make a mess? And then the thing to really be able to recall, well, I guess you do need that. You need to know which side's the opposite and adjacent. But which ratio is the sine? Which ratio is the cosine? Which ratio is the tangent? So that's kind of what this is for, right? It gives it away. SOH, sine is opposite over hypotenuse. So if I'm looking at this triangle and this angle, opposite over hypotenuse, that ratio, you would take this number first and put it over this number second. Somehow I think of an arrow like that. So that's the sine of that angle. By the way, the sine over here on this triangle, there's the 90, here's my angle, here's my opposite, here's my hypotenuse, so that would be the sine. So there's your sine, there's your sine, here's your sine. No. And then let's put the cosine in a different color maybe. So remember, cosine, it's this one in the middle, CAH. It's the adjacent over the hypotenuse. This way, that's the cosine. That's the cosine, Tony. So AH cosine, okay, and let's have maybe a nice green tangent or something. Tangent, what's that? That's OA, opposite over adjacent. So that would be coming this way. Kind of slaps you in the head, right? You're here. So you start on the opposite side and then you come furiously towards the adjacent side and get yourself right in the chin. Ow! The tangent has nothing to do with the hypotenuse. It's another way of remembering these things. So over here on this triangle, if this is your angle and you happen to touch the screen in the wrong spot, it will scroll like that. But anyway, if this is the triangle and this is your angle, then opposite over adjacent, you're looking this way, right? That would be the tangent. So I will write TAN for tangent, and over here I will write TAN for tangent. Now, part B. There are exactly 6 situations that you can face, which makes this kind of nice, really. There's only 6 different situations, so I have one example from each possible situation. So if you could master all of these, you're golden. What are the 6 cases? Well, here's one of them. This is the case where, and maybe I'll define it when I'm done actually. Let's look at this triangle. Here's the angle. We have this side, we have this side. Or we don't have this side, we want this side, but we have this side. So those are the 2 sides that are involved. Notice that these 2 sides are the, what now? That would be the opposite, right? This would be the hypotenuse. And so we've definitely got a SOH situation. And this time, since I know the angle, I'm not going to write sine theta. I'm going to write sine 22 degrees. I know it's 22 degrees. Put that there. So sine of 22 degrees is, now you're supposed to take the opposite first and put it on top of the hypotenuse, which I believe that was an 18.7 before I mucked it up. Unmuck. Okay. So we're in pretty good shape here, folks. We got to solve that equation for x is what we got to do. Now this sine of 22 is just a decimal. You can look it up in a table. Remember that trig table last time? Or if you want, you can push buttons on your calculators. No shift there. Here, you just hit the sine, just the sine of 22. And if you do that, you'll get something like, what is this, 0.3746065. So that's what the sine of 22 degrees is. I don't really feel like writing down all this decimals and schlepping them along. So what I do is say, look, that's just some kind of decimal. Cool. what I got to do is I got to solve for x. Here's my x. What do I do to it? Sheesh. Here's my x. So what I got to do to it, it's highlighted, how's that, is we got to basically get rid of that 18.7. Now notice we're dividing by 18.7. If you don't want to do that, or if you want to undo that, you would instead multiply by 18.7. You can think of this as over 1 if you want. So basically I multiply both sides by 18.7, and I end up with, over here it's just x. X equals, it's 18.7 times the sine of 22, and you just type that right in your calculator like that. You type the 18.7, you can just hit the sign, it will know that it's supposed to multiply. Put the 22 in there, close your parentheses, hit the equals, boom! I got a 7.00514, so on, so on, so on. Now what I'm going to do, because I'm going to ask you to do this on the homework, is I'm going to round this to what's called 4 sig figs. What is a sig fig? Every number you see starting with the 7 is a sig fig. So starting with the 7, I count 1, 2, 3, 4. So 7.005 would be my answer to 4 sig figs. So the length of this side is just about 7. So if this were drawn to scale, you'd say, hopefully it would look right. That's one of our situations. Okay. This situation formally is, it was a sine and the x was on top. So all we had to do is multiply both sides by the number. All right, what's this one over here? Well, here's my angle again, right? So this is not the opposite, that's the opposite. Here's the opposite here. This is the adjacent. Adjacent over hypotenuse. That's a cosine. So again, I don't have theta, I know theta. So it's cosine of 22 degrees, that's what it is. And you put the adjacent x on top of the hypotenuse 18.7. And we have a very similar situation. It's like, here's the x that I want. What I don't want is that 18.7 dividing there. So if somebody divided something by, if somebody divided something by 18.7 and you wanted to get back to where you were, you'd have to multiply by 8.7, right? You would do what's called the opposite operation. So that's a multiply. So the opposite of dividing by 18.7 is multiplying by 8.7. That's kind of the official math explanation. I just think in terms of canceling, right? So when you multiply fractions, you can just cross cancel like that. So that's the thing to do, is to multiply both sides by an 18.7. And so what is x? X is, type it in, 18.7, hit the cosine button, hit the 22, bammo, 17 point, I got what, 3, 3, 8, 3, 3, 8, that's interesting. If I want 4 sig figs, that's my first sig fig, 1, 2, 3, 4. So actually round, so that 8 means I should round that up to a 4. So 17.34 would be my answer to 4 sig figs. Okay, I want you to be sure that you can, in addition to learning your SOH-CAH-TOA stuff, setting up these equations and solving them, add in a little sig fig action. Make sure you can do the sig figs things. So notice it's not the same as rounding to 4 decimal places. It's 4 significant figures. And a number is significant as soon as it shows up right there. Boom, that's significant. 1, 2, 3, 4. So 17.34. And again, make sure you round. Don't just cut it off. 2 down. What was this situation? Well, it was a cosine with the x on top. What do we got here? We did a sine and a cosine. Doesn't seem like a tangent should show up right about now. So looking at this right triangle, there's the angle that we know. And remember, if I come through the middle of the triangle, I'd get to the opposite side, and then here's the adjacent side here. So it's OA, it's TOA. So it's definitely TOA. And so we would say, okay, the tangent of, and I know the angle is 22 degrees, is OA, opposite 18.7, goes on top of adjacent x. Okay, it is a tangent. Do you notice something different, though? Where's our x? It's on the bottom. Oh, who did that? So notice that we're not going to do the old multiply by 18.7 trick. That doesn't work Because remember, you're supposed to cancel something, right? You can't cancel that. That's not a cancel. Put a big question mark there. And then preferably you did not write that down. So I'm going to try to unwrite that down. It doesn't work that way. What you got to do instead, if you're going to cancel anything, you're going to have to cancel the x. I mean, you don't want it on the bottom, that's for sure. So we're going to have to cancel the x. So that means we're going to have to multiply both sides by x, right? Cancel the x's. So this is going to be kind of a two-step problem because now I've got x times the tangent of 22 on the left side and just 18.7 on the right side. Okay. Now what do? Well, this is the part where you get out a new color, purplish, and you say, well, here's my x, right? There's my x now. And what I don't want is somebody to come around and multiply it by that. So I'm going to have to take that back, so to speak. I'm going to have to divide it. Always the opposite operation. Or again, I always just think of canceling. I need to cancel that tangent 22 by putting a tangent 22 underneath. So notice the difference here. For these problems up here, our answer in the calculator was always to take like the side times the cosine. Side times the sine. Here it's the side divided by the tangent, okay? So, oh boy, okay. 18.7 divide by tangent 22, close parentheses, boom. 46 point, I got like 284, which is enough for me to find 4 sig figs. 1, 2, 3, 4. So you look at this one to know whether you have to round up or down, round down. So 46.28 would be our answer there. So this is the third type. It was a tangent, but it was also different because x was on the bottom. So pretty much right now, once you've seen x on top and x on the bottom, and if you know how to handle both of those situations, you'll be in good shape. Let's look at this one. Well, oh man, who invented these things? Okay, so anyway, here's my right triangle. It's definitely a right triangle, and again, that's very important. Don't even think about this if you don't have a 90 degree somewhere. Don't even think about it. It will be so wrong. It'll be so embarrassing. You don't want to do it. But anyway, this is a right triangle. Here's the angle that we're interested in, our focus angle, whatever you want to call it. And so that would be the hypotenuse, of course. This is not the opposite. It must be the adjacent, huh? So we've got adjacent hypotenuse, CAH, cosine. This is one of those cosine situations. So I know the angle again. So cosine of 52 degrees is, take the adjacent first, 214, put it over the hypotenuse, which is the x. Ooh, x is on the bottom again. See, it happens. It happens. So I could do the very same thing as I did over here. What did I do over here? Well, let's get a different color here. Come on, come on. Okay. I did this two-step where first I canceled the x's, and then I had to cancel the tangents, right? But do you see what ended up happening? I ended up here. What I ended up with was dividing by the tangent instead of multiplying. Or in other words, let me put it this way. Oh, not you, no, you, that's better. But purple, okay. What you do is you swap places. This is the shortcut of all shortcut. You can just swap places. You'll get the same thing. If you don't trust me, do it yourself. Multiply both sides by x, and then when you're done, divide both sides by the cosine of 52, and you will, I guarantee, get this very same result. You will get x is 214 on top of the cosine of 52. Okay, works every time. I hope you will let me take that shortcut because it's wonderful. So if x is on the bottom, what you can do is you can swap along the diagonal like this. You're going to be dividing. So if x is on top, again, let me scroll back up. If your x is on top, you ended up multiplying, right? Because you had to multiply both sides by the number underneath. So if x was on top, I ended up multiplying by the trig. But when the x was on the bottom, I end up dividing by the trig. That's kind of the rhythm here. So I should finish this one. I should stop coughing somehow. 214 divided by cosine of 52. Boom! we got 347 point, what do I got here, like 5936 or something. I'm writing a lot of decimals here. But to find 4 sig figs, the 3 is my first sig fig. 1, 2, 3, 4. I'm going to round to there. The 9 is telling me, oh yeah, round up. So 347.6 would be our 4 sig fig answer. That's 4 down. So again, you can see how I define the 6 problems. Either x is top or bottom, and it's either sine, cosine, or tangent. So you end up with 6 scenarios that you'll have to face in this world, I guess. You want to try these last 2 yourself while I try to cough. Pardon me. Try these 2 yourself. You can pause. Too bad I can't. But you can pause and try these and then come back and see how you did. Here's our known angle, 18 degrees. We'd like to know what this side is, which, by the way, is the opposite. And we have this side, which is the adjacent. So this is opposite adjacent. This is one of those TOA situations. And so the formula I'm writing is the tangent of that angle, 18 degrees, is equal to, put the opposite first, x over the adjacent, 5.98. Now this is a nice one because all you got to do to solve is multiply both sides by the 5.98. That's a multiply. Put it over 1 if it looks better to you. It looks better to me. So 5.98 times the tangent of 18. Where did I put my calculator? Here it is. 5.98 times the tangent of 18 degrees is, and I'm getting a 1.94, like 301.9783. That's what my calculator says. So we're just reporting the answer. All we need is 4 sig figs, and so we're gonna kind of round there. So 1, 2, 3, 4 figures. The 0 says don't round anything anywhere, just leave it where it is. Round down, you might say. 1.943. That's what that side is. Last problem. Here's our angle of reference here. That's our point of view. Now, with that as our point of view, this would be the opposite. This would be the hypotenuse. So we're talking about a sine here. So I'm going to write the sine of that angle, and that angle is 58.3 degrees, is equal to, put the opposite over the hypotenuse. The opposite is 897. It goes over the hypotenuse, which is x. So this is one of those situations where the x is on the bottom, so it doesn't work to multiply both sides. Well, it does work to multiply both sides by x. You'll cancel the x. It's just that then what you're going to have to do is you're going to have to divide both sides by this. And so x is equal to 897 over the sine of 58.3 degrees. Although usually what I will do myself, because I've done this 8 million times, I know it works, is I say, oh, I can just trade places. The x and the sine 58.3 can just trade places, and so here you are. X is equal to 897 over sine 58.3. Cool. Let me push buttons now. 897 divided by the sine of 58.3. Bammo whammo. I've got a 1. No, I don't. Oh, come on, you. Don't give me any clues. Just give me a pen. There we go. So I've got x equals, what does this come out to be? 1054. And I got like a 0.288067, which is not really important. By the way, the calculator gives you all these nice juicy sig figs, if you will. And that's because if you happen to know that this is 897.000000, and this is a 58.3000000 degree angle, then, well, that would be your answer. You might actually need more zeros, actually, but whatever. If you knew these numbers exactly, then this would be the answer. That would round it to, what do we got, 10 sig figs or something? Usually, we don't know that. We have approximations. These are measurements. This one has been measured to 3 sig figs. This one has been measured to 3. Actually, angles are tricky with sig figs. I just say, 1 decimal place is good no matter what your angle is. And it's roughly the same as having 3 or 4 sig figs. Anyway, so I'm going to report with 4 sig figs. That's usually my convention. And I say, okay, well, that would mean I'm going to well, I'm going to 1, 2, 3, 4. So I'm going to go right up to the decimal, and the 2 says don't round it up, just leave it. So 1054, that would be a good answer for right here. 4 sig figs is a good working rule. Like if you just always use 4 sig figs, your answer is never going to be that far off. And sometimes I use, the rule I learned in school was to carry 5 sig figs throughout your calculation, but then round your answer off to 3. Now, we were only given 3 in the first place, but still, we would carry 5 sig figs throughout our calculation, and then at the end, we would round off to 3. If you just keep rounding things to 3 sig figs all the time, all the way through your calculation, your answer is not going to be the same as mine. Just try it to prove it to yourself sometime. But anyway, there it is. Okay, I think we're done.